Buongiorno and welcome to the last data models presentation for CIS 3107 database modeling. We will be covering degrees of data abstraction from section 2.6 in our text. In this last presentation, we will learn about the advantages and disadvantages of various data models and how data models can be classified by their level of abstraction. In the following slides, we will compare the advantages and disadvantages of each of the various database models we have discussed so far. Please return to this table 2.2 here or in your book for an overview of these comparisons. The hierarchical model's advantages are that it promotes data sharing and conceptual simplicity and data integrity through the parent/child relationship. The database security is provided and enforced by the DBMS, as well as the model's efficient one-to-many relationships. The disadvantages to the hierarchical model is that it requires knowledge of physical data storage characteristics. The navigational system requires knowledge of hierarchical path. The changes in structure require changes in all application programs, which in turn leads to implementation limitations. Also, the model does not have data definition and lacks standards. The advantages of the network model are its flexibility. The data owner/member relationship promotes data integrity, its conformance to standards, and that it includes data definition language, or DDL, and data manipulation language, or DML. While its disadvantages are the model's system complexity limits efficiency, navigational system yields complex implementation, application development and management, and finally, the structural changes require changes in all application programs. The relational model's advantages are its use of independent tables, which promotes structural independence. Its tabular view improves conceptual simplicity. Its ad hoc query capability based on SQL, the way it isolates the end user from physical level details, and the model's improved implementation and management simplicity. While the RM's disadvantages are that it requires substantial hardware and system software overhead, its conceptual simplicity gives untrained people the tools to use a good system poorly, and that it may promote information problems. The entity relationship model's advantages are that its visual modeling yields conceptual simplicity. The visual representation makes it an effective communication tool, and it is integrated with the dominant relational model. The ERM disadvantages are its limited constraint in relationship representation, the lack of data manipulation language, and that there is a loss of information content when attributes are removed from entities to avoid crowded displays. The object-oriented model's advantages are that semantic content is added. The visual representation includes semantic content, and inheritance promotes data integrity. The disadvantages of the OO model are that slow development of standards caused vendors to supply their own enhancements, which compromised a widely accepted standard. Its complex navigational system, which requires a steep learning curve, and a high system overhead, which slows transactions. The NoSQL advantages are that it provides high scalability, availability, and fault tolerance, uses low-cost commodity hardware, supports big data, and its key value model improves storage efficiency, while its disadvantages are the complex programming requirements, the lack of relationship support, and transactional integrity support, and in terms of data consistency, NoSQL provides an eventually consistent model. Please review Table 2.3 for a comparison of basic data model terminology. This table leads into our next topic, for if you were to ask 10 database designers what a data model is, you would end up with 10 different answers depending on the degree of data abstraction. A database designer starts with an abstract view of the overall data environment and adds details as the design comes closer to implementation. Using levels of abstraction can also be very helpful in integrating multiple and sometimes conflicting views of data at different levels of an organization. In the early 1970s, the American National Standards Institute, ANSI, and Standards Planning and Requirements Committee, SPARC, defined a framework for data modeling based on degrees of data abstraction. The resulting ANSI Spark architecture defines 3 levels of data abstraction: external, conceptual, and internal. You can use this framework to better understand database models, as shown in Figure 2.7. In the figure, the ANSI Spark framework has been expanded with the addition of physical model to explicitly address physical level implementation details of the internal model. The external model is the end user's view of the data environment. The term end user refers to people who use the application programs to manipulate the data and generate information. Because data is being modeled, ER diagrams will be used to represent the external views. A specific representation of an external view is known as an external schema. To illustrate the external model's view, examine the data environment of Tiny College. This figure presents the external schemas for 2 Tiny College business units: student registration and class scheduling. Each external schema includes the appropriate entities, relationships, processes, and constraints imposed by the business unit. Also, note that although the application views are isolated from each other, each view shares a common entity with the other view. The conceptual model represents a global view of the entire database by the entire organization. That is, the conceptual model integrates all external views, entities, relationships, constraints, and processes into a single global view of the data in the enterprise. Also known as a conceptual schema, the conceptual model is the basis for the identification and high-level description of the main data objects, avoiding any database model-specific details. The conceptual model yields some important advantages. First, it provides a bird's eye or macro view of the data environment that is relatively easy to understand. Second, the conceptual model is independent of both software and hardware. Generally, the term logical design refers to the task of creating a conceptual data model that could be implemented in any DBMS. An internal schema depicts a specific representation of an internal model using the database construct supported by the chosen database. Because the internal model depends on specific database software, it is said to be software dependent. Therefore, a change in the DBMS software requires that the internal model be changed to fit the characteristics and requirements of the implementation database model. When you can change the internal model without affecting the conceptual model, you have logical independence. However, the internal model is still hardware independent because it is unaffected by the type of computer on which the software is installed. Therefore, a change in storage devices or even a change in operating systems will not affect the internal model. Once a specific DBMS has been selected, the internal model maps the conceptual model to the DBMS. Because this course focuses on the relational model, a relational database was chosen to implement the internal model. Therefore, the internal schema should map the conceptual model to the relational model constructs. Likewise, because a relational database has been selected, the internal schema is expressed using SQL, the standard language for relational databases. The physical model operates at the lowest level of abstraction, describing the way data is saved on storage media, such as magnetic, solid-state, or optical media. The physical model requires the definition of both the physical storage devices and the physical access methods required to reach the data within those storage devices, making it both software and hardware dependent. Since the now dominant relational model is aimed largely at logical level rather than the physical level, it does not require the physical level details common to its predecessors. When you can change the physical model without affecting the internal model, you have physical independence. Therefore, a change in storage devices or methods and even a change in operating system will not affect the internal model. The levels of data abstraction, summarized by the American National Standards Institute and the Standards Planning and Requirements Committee, ANSI and SPARC, are described in 3 levels of data abstraction: external, conceptual, and internal. The 4th and lowest level of data abstraction, called the physical level, is concerned exclusively with physical storage methods. There are many advantages and disadvantages to each data model. All models discussed are data independent. The hierarchical and network models exhibit no structural independence, while all the others, relational, entity relationship, object-oriented, and no SQL, do. Data modeling requirements are a function of different data views, global versus local, and the levels of data abstraction. The American National Standards Institute and the Standards Planning and Requirements Committee, ANSI and SPARC, describe the three levels of data abstraction as external, conceptual, and internal. The fourth and lowest level of data abstraction, called the physical level, is concerned exclusively with physical storage. Thank you for watching our Unit 2 Part 3 presentation. The diagrams and content of this lecture were derived from our textbook. For a more detailed treatment of these concepts, please review pages 57 to 64 in your textbook.